find the distance, okay, the distance of what? OP. So we say that the distance OP of the line segment OP, we say this will be the square root of what? So for the OP, we just say that is x minus a here. So we can even say that x minus a square plus y minus what? Minus b square. X minus a square, y minus b square. But also that distance is equal to r square. This distance is equal to r, not r square, is equal to r. Right? So if that's the case, that we say, okay, fine. So now we can say that r, so we can say that, okay, square root of x minus a square plus what? Y minus b square is equal to r. You agree? You learn distance. We used to teach O-level students, so ordinary secondary students, how to find the distance between 2 points in the xy plane by using the distance formula. So we taught you. I have just reminded you. It means, let me recall, let me just write the distance formula. We used to write that the distance formula, the distance from A to B, this is equal to the square root of what? Of x2 minus x1 square plus what? y2 minus y1 square. So for this case, this is correspond to x1, this is x1, this is x correspond to x2, and this is correspond to x1. This correspond to y1, y2, this corresponding to y1. So remember, corresponding to what? y2, this corresponding corresponding to x1, corresponding to corresponding to x2, and this a corresponding to x1, y corresponding to y2, b corresponding to y1, according to this formula. So that's what we've done again. So now we can square both sides, right? Can square both sides of the equation. So after we square both sides, we get x minus a square plus what? Y minus b square. This is equal to radius of the cycle square. This is very interesting equation. But I want to show you the alternative, the second technique that you may use to derive that equation quickly. So that should be what the first step. So alternative. If you don't, you say that it's enough. You want to prove whether it is true. So alternatively, we go for the first step. The first step, we say that recall and use Pythagoras theorem, right? Pythagoras theorem. And that Pythagoras theorem, just to remind you, you say that c square is equal to b square plus a square, right? So what is c? So c is a hypotenuse. This b possibly might be adjacent, and this might be opposite of the right angle triangle. So if you relate, you can find that, okay, c square for that case, c square corresponding to the line segment OP square. And this is equal to what? B square might be corresponding to OQ, right? Square. Plus what? PQ corresponding to what? A square. Corresponding to A square. Right? Okay, well. So OP, this is R square. Right? And then it's OQ. OQ, the distance between OQ, it is x minus a, it is x minus a square, right? Square, and then plus what? Plus, we have b minus b. So you have b minus b square, right? Because of this OQ square, okay? Or in simple words, just to simplify life, we can say that OP square, this is equal to what? This is equal to R square. right? OP square is equal to R square. Okay, fine. So OQ square, we can find it by taking x minus a square plus b minus b square. X minus a square, b minus b is, okay, open and close bracket is square. We are using distance formula, right? So we say that OQ square, it will be x minus a square. So suppose that this is first equation, and suppose that this is second equation, and suppose that this is third equation. Then we have again what? PQ, right? So PQ, we say that, where is PQ? PQ. We say that we take x coordinates, x minus x. X minus x should be squared because of this is square. Plus what? Y minus b squared. So x minus x is 0. So 0 squared is 0. So it means that the distance of OP square, this is equal to y minus b squared. Suppose that this is question 4. So you go to what? You got the fifth state. The fifth state, we say that substitute equation 2, okay? And then equation 3, and the equation 4 into equation 1. So if we do such kind of the substitution, then we get equation of the translated cycle. Remember that the concept of translating, this is common for the every type of the conic section. We are going to study also translated. It means we are going to study, for example, a parabola parabola centered at origin, and a parabola translated whether in first quadrant of XY plane, or second quadrant, or third quadrant, or fourth quadrant. Also, I'm going to teach you about how we can find the equation of the ellipse centered at origin. And I'm going to teach you how to derive the general equation of the ellipse, of the translated ellipse, whether in first quadrant, or second quadrant, or third quadrant, or fourth quadrant. That's not enough. Just to make the beauty of conics to your life. I will teach you that how you can derive the general equation of the hyperbola centered at origin. And also I will teach you about how you can derive the general equation of the translated hyperbola to the first quadrant or second quadrant. Mainly first and third quadrants for the parabola, hyperbola, and ellipse. Once we translate them, we might translate 2 quadrants at a time according to the year shape. So stay connected, stay faithful, just join me. I will explain in simple language so that no need for you to claim, right? You will understand, and even you will be a good teacher to your children who will be the future generation. Okay, so now after substitution, what do we say that? Okay, fine. Now where is equation 1? So it means that if you want to substitute there, you have r square, then you have xe, so we have again OQ. OQ, which is what? X minus a square plus what? Y minus b square. So again we get the same equation like the one that we have there. So in 2 alternatives, so in 2 ways of deriving the equations, we get the same equation. So that's why that we say that now, therefore, keep this in your mind, the general equation, right, of the cycle, right, of the translated cycle, of the cycle, of the translated cycle, of the translated cycle. We are going to deal with translated cycle in many cases. Translated cycle is given as x minus a square plus y minus b square. This is equal to what? R square. Keep this equation for the rest of your life. Very important. You can also keep the one that you have underlined there. Okay? So, now I heard from my heart that the student who is asking what the format of the questions which he asked me to derive are a translated cycle. Okay. So that will be example. So let me give you the style of the questions which they used to ask in exam. Example 1. This is about the derivation of the cycle. So you can find out derive with aid of diagram, maybe derive what the equation of the cycle centered at the origin. So solution of this equation, we say refer my notes. Again, for the second equation, we find the questions stating like this one, example 02, with 8 of diagram, derive the general equation of translated cycle with center A, B, and the radius R. So solution of this question, refer my notes. Okay? So you have everything in your mind now. Then before we do numerical or quantity, before we solve some equations of some problems in questions of the cycle, I want to teach you the set derivation for session 2, which is derivation of the equation of the cycle. Passing through 3 points. Passing through 3 points. So when you say that passing through 3 points, yes, passing through 3 points. Very important part, because we are going to get again, we're going to express the equations of the translated, the equation of the translated what? We're going to express the equation of the translated cycle in another format. Okay? So we have a problem, or we have a question, an example here. So like, let me put the example, and then I'm going to teach you how we can solve that example. Okay? So this will be example 3. Do you enjoy the beauty of basic engineering and scientific mathematics? Tell me in the comment section, please. Show that this is the format of the question. Show that the general equation of the cycle centered at t negative f, comma, negative G passing through three through 3 points is given as this is given as x square plus y square plus 2 fx plus 2 gy plus c is equal to 0, whereby c is equal to c is equal to a square plus b square minus r square. R square. Okay, so this is the problem. You can pause the video a moment, take a piece of paper that we call the rough paper, and then try to answer the question yourself. Right? Let me repeat. I say that you can take a piece of paper, right? Take a piece of paper and try to answer this question yourself. And then, and after, when you finish, you can continue. You can click the play button of the video so you can see the corrections and you can correct yourself what you've done. So you can align yourself, because we want, our main objective, we want to teach you how to be, or how to, how you can be active and how you can live from spoon feeding protocol into the state, or the state that you can solve problems. So remember that this is active learning program. Okay? So solution. So I believe that the student who is watching me, the diploma students, they've paused it and they've begun to answer that. It's not a difficult question. The answer is already covered, but in a different style. So I will be teaching you how to derive different mathematical equations by following steps. I'll be teaching you how to solve any problem, any mathematical problems, right? Any basic mathematical or scientific mathematical problem by following number of steps. First step, I write what are we going to do. Second step, I write what are we going to do. Third step, I write what are we going to do. So it will be easy for you to review all the the notes once that you don't have enough time, because it's very simple. You just go, you read the first step, you read the text you have written, so what are we going to do in the next step. It means what are we going to do below of this sentence. So that the technique God has given me, and it's really working powerful more than you think. Try to adapt it and then you will find out how. So the first step, okay, we'll be given x, y. We know that these are the coordinates of the cycle at any points of the cycle. F and G, they have been saying that these are the center of that cycle. Okay? So we have again y, and we have yes x plus c. So here's something which is new, because if we refer our fundamental equation of the translated cycle, we have x, a, y, r, d. So you have how many letters? 1, 2, 3, 4, 5. So in this equation that we have to show, we have 1, 2, f is a new term, a new vocabulary for us, x is only, g is a new terminology, and c is a new terminology, however, that has been not defined. But let us open the chiefty of example 3. So the first step, recall the general equation of the translated, because any cycle that passing through 3 points is a translated cycle, or the translated cycle. What is general equation? I told you that is x minus a squared plus y minus b squared is equal to r squared. What does r mean? Radius of the cycle. What does ab mean? Center of the cycle. And then xy are any point on the circumference. Any point along the cycle. Okay. At the first stage. So with this one, we say that the center is a positive a comma b. Okay. While the center of this new cycle that you have to show that its expression is negative f comma negative g. So well, second step. Second step, we say good. Okay, compare what? The center, not compare, yeah, okay, yes, compare or equate. Yes, compare the center of 40 of the translated cycle and the given cycle. What does this mean? So we are doing what we have written there, what we have written above. So the center of the general equation is a comma b. The new center is negative f comma negative g. So for this case now, a will be corresponding to negative f and b will be corresponding to negative g. Right? So, okay, because this is mathematics and these are kind of equation, we can say that this is equation 1. No, suppose that this is equation 1, because we like equations in mathematics. Basic engineering mathematics is beautiful. Okay? And then b is equal to negative g. Right? Is equal to negative what? G. Okay. So if that's the case, what do we say now? We say good. We go for the steady state. Steady state, we say that substitute equation 2 and b equation 3 into equation 1. So if you substitute, we get that x minus negative f, and then we have open and close bracket square plus y minus negative g, and this one square is equal to what? Is equal to square of the radius. Okay, so if that's the case now, we can simplify. So open the bracket here, the inner bracket. Negative is positive. So you have x plus f square. And then negative is positive. So we have y plus g square is equal to what? Is equal to radius square. Alright? Radius square. And then, what do you say? If that's the case now, we go to the first step, because we have to show this equation. This destination should show at the end, we should also show that this equation is equal to this one. Okay? So the first step, we say that, suppose that this is a new equation, because we formulated the new equation, this is equation 4. So you say that expand equation 4. Expand left hand side of 40 of equation 4. How do you expand? So you remember that. It means you take x plus f, let me remind you, possibly you forgot. This is equal to x plus f times 40 x plus f. Right? So simply x plus f square this is equal to x times x, it is x squared, x times f, it is xf, and then f times x, it is fx, and then f times f, it is f squared, right? So you say that this is x plus f squared is equal to what? Is equal to x squared plus 2xf plus f squared, right? Okay. So then we say that is similarly for y plus g, if you follow those procedures, the final response after expansion, because this is what you have covered in Form 2, is equal to 2 gy plus what? G squared. Right? So if this, we can say that is question 5, and this one is question 6, then we can go to what? To the physics table. Physics table, we say that substitute what? The two equations, question 5 and the question 6 into equation 4. So if you substitute, what are you going to have? You're going to have a long equation. X squared plus twice fx, okay, because this is the coefficient of x, and hence we say that plus what? F squared, okay, this is all about after expansions of this term, y squared plus what? Twice gx plus what? G squared is equal to r squared. Interesting. You enjoy the beauty of basic engineering, mathematics, and scientific mathematics? Tell me in the comment section. So now, our final equation is x squared plus twice g y plus twice fx plus g squared plus f squared. I didn't change anything there. It's equal to r squared. Okay. So our final equation does not contain g squared, r squared, and the f squared. So what should you do? So we say that we have to make sure that we remain, we have plus y again. So we have plus y. So I forgot that we have plus y, or we have plus y squared, and this is equal to r squared. Right? That is good. Okay, so we have to, because we have again another aiding equation, if you remember that, you'll be given that c is equal to f squared plus g squared minus r squared. So this is, we call it assistant equations on your proof. Okay? So if that's the case now we say that fine. So we should make x squared plus y squared plus 2gy plus 2fx the subject. Okay? So in order to make the subject, we mean that it remains is x squared plus y squared on left hand side plus what? Plus 2fx plus 2g plus 2gy plus 2gy. Okay? And then because we have this equation and we are missing, what are we lacking in the given equation, final equation is c. So to introduce c, I'm sorry, we are not going to make x squared 2gy 2fx plus y squared the subject. No. We are going to bring this r squared on the left hand side of the equation. Okay, so we have x squared, this one, y squared, this one, 2fx, this one, 2gy, this one, and then we say that plus g squared plus f squared, right? And then minus r squared, this is equal to what? To 0. Right? And then we say that the sixth step and the last step, we say that given that C is equal to F squared plus G squared minus R squared. So suppose that this is question 7, this is question 7, and suppose that this is question 8. Okay? Okay? So we say that substitute equation 7 into question 8, excuse me, into equation 7. So if you do such substitution, we are going to have x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. Right? Is equal to 0. So then we say that hence shown as required. We just say that hence shown. And at the end of 40 of solving 30 problem. Does it interest? Is it interesting? Is it interesting? Tell me in the comment sections that if it's interesting to you. Do you enjoy it? So okay, so then so we are going to use this is another general. So okay, so you say that the general equation of the cycle passing through derivative passing through the reference passing through the derivative through the reference is given as x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. Okay? This is very important equation. Okay? So not before. When we'll be solving problems, because the next step now it will be problem solving. I'm going to solve some of the numerical, just equation, some of the mathematical equations of this part, of this concept that you have learned, not before. So in solving, or in dealing with above equation, in dealing with solving problem or dealing with solving problems relating to the above equation. Okay, this equation is also useful. You see the way I'm teaching you, I used write which equation? This equation that you said C is equal to F squared plus G squared and then minus R squared. How is it useful? This equation will help you to get radius of the cycle. How? F squared plus G squared and then we say that minus C. Okay, that the square of delta, that is radius square. That is radius square. Wow. So if it's radius square, so you say that if you want to find the radius of the cycle, is the square root of 40 of F squared plus G squared. Okay? Plus G squared and then minus C. So again, remember this question for the rest of your life when you are dealing with conic section. We're dealing with problems solving of the equation of the cycle. Well, tell me in the comment section, did you understand? Tell me. Give me comments in the comment section. If you have any questions, didn't understand any point, let me know in the comment section. So let me get the feedback, the practical feedback in the comment section. Tell us again you're enjoying this stuff, from which institutions or college or university, from which regions of United Republic of Tanzania, from which country. Okay, if you enjoy this material in African continent, in America, North America or South America, in European, in Asia continent, in Australia. So tell us that in which country you are from, and tell us in which city you are from, if you are from Tanzania, in which district, in which institutions, in which college, or in which university, and tell us also that in which continents are you from. Right. I believe that you have enjoyed this session, lecture 2 of derivations of the equation of the cycle. Right? I believe that you have enjoyed. I have enjoyed. So I would like to thank God who has been with me during the preparations of this content, and even He has been with me in such a way that I taught this session, lecture 2, in a different style compared to what I used to teach my students for almost 5 years consecutively. I thank God also we have given you a chance to watch this lecture, and may God bless you abundantly, and may God be with you, and may God open your mind to understand what I've been teaching from the beginnings to the end. And not only to understand, but also to think, where can I apply this information to solve a real life problem. So I'd like to invite you, welcome again, welcome the inside. I would like to welcome you into lecture 3 of equation of the cycle. And I'd like just to tell you in advance, in lecture 3 or session 3, I'm going to teach you how you can solve problems in cycle, right? How you can solve problems by using these equations of the cycle that you have been deriving. So it means that you have to make sure to review these contents as well as possible so that you understand the lecture 3. So may God bless you. Remember to subscribe onto our YouTube channels that called the Online Diploma POLYINSTIT of Tanzania, in square bracket OLENJOLAI. Share it with your colleague. Remember to read the descriptions of this video. Also remember that to use the comment section, to read the comment sections, the comments from other students worldwide, so that you can enjoy the beauty of basic engineering and the scientific mathematics. So I would like to meet you in the lecture 3 in order to enjoy the beauty of basic engineering and scientific mathematics. So stay blessed. May God bless you.